Hello everybody, welcome to our portfolio presentation. Today we have question number 6, which is all about parallelograms. So let's hop right into it. Question number 6. Parallelogram ABCD has sides AD, BC as 6 centimeters and AB and CD as 25 centimeters, and angle ABC is equal to 136.4 degrees. So first I'm going to be tackling part A, which is to find the length of diagonal AC. So first let's throw up that diagram right there. So we have our given information, so that long side is 25 centimeters and the short side is 6 centimeters. So the first thing that we can see when we want to find the diagonal, right? So we know that with our good friend Pythagorean theorem, if we can just find a triangle that has this diagonal length as its hypotenuse, then it'll be easy money. So that's exactly what we're going to do. So the way we do that is by adding in this imaginary little part so we can make this bigger triangle later. But first we got to figure out what these lengths are. So to do that, we have our given information. So from that we can find, oh okay, well if this is going to be a triangle, then this right here is going to be, even though it doesn't look like it because I didn't draw it very well, this is going to be a straight line. So we know that this whole angle is going to be 180 degrees, and by subtracting 136.4 from 180, we get that this little pink area right here, purplish pink, magenta if you will be 43.6 degrees. So now that we have that angle, well, what do we do with it? Well, we have our SOHCAHTOA operations, and with those, well, we know here, so we have these lengths, right? And we have the angle. So we know that sine is going to be the length of the opposite side, so this yellow right here, over the hypotenuse. So we can use this angle to find out this length. And we do that by taking the sine of this angle, 43.6 degrees, and then multiplying it by 6 centimeters, which is the same as this over here. It's going to be 6 centimeters, this hypotenuse right here. And through that process, we get that this yellow length is 4.138 centimeters. And we can repeat this exact train of logic with this red side down here at the bottom. So we know that cosine is going to be adjacent over hypotenuse. So this is the adjacent side. And by doing the same thing as we did here, we can find out that this side is 4.345 centimeters. So perfect, so we know these two things. So now that we know that, we can move on to finding this big hypotenuse of this overall triangle right here. If you can see what I'm kind of messily highlighting right here. So to do that, it's easy. Pythagorean theorem. This is going to be this side, this short leg, and then to find the length of this long leg, all we got to do is take 25 centimeters, which is this length right here, and add it to 4.345 centimeters, so we're going to do that, and then put that as a length as a whole. And then we complete Pythagorean theorem with both these lengths, and we get that the length of the diagonal, or the hypotenuse of this big triangle, is 29.635 centimeters. And I will hand it off to Leila to tackle the rest of this problem.
For B, we're going to need to find the measure of angle BAD right here, and the length of diagonal BD right here. So first, to find the measure of angle BAD, we're going to use the transversal rule. Since we know that AD is technically a transversal across parallel lines AB and DC, we know that this angle right here is just going to be 180 minus 136.4, because these angles have to add up to 180 degrees. Therefore, angle BAD is 43.6 degrees. So we've already finished half of the part that we need to finish. Next, we need to find the length of diagonal BD. To find that, I'm going to create a right triangle with the base of the parallelogram and call this point P. and we're going to find these two lengths right here and use the Pythagorean theorem to find length BD. I'm going to label this length right here as Q. Next, we know from the first problem these two lengths right here. They were positioned over here in the first part, but we can also put them over here and they will be the same as the first problem. These two lengths are 4.345 about and 4.138 approximately. These are rounded decimals. We're going to be using the stored values in our calculators when we actually calculate the answer. So to find Q, which is the first one we're going to find, we're going to need to do DC minus PC right here. Now we know what PC is. It's the same as this length right here. And we know what DC is. It's 25 centimeters as set up here. So Q is the same as 25 minus 4.345, which is the same as 20.655 centimeters. And if you do it with the stored values in your calculator, it rounds to about the same amount. Next, we're going to need to find length BP. Length BP is just the same as this length, which is 4.138. So we already have that length. Next, we're going to use the Pythagorean theorem to put it all together. So BD, which is the length right here, is the same as the square root of Q squared plus BP squared. And that is all about 21.065 centimeters. So we found both of the parts we need to find, the measure of angle BAD right here and the length of diagonal BD right here. On to the last part, we need to find the area of the parallelogram ABCD. Now I have the base height right here. We don't need to know the length of this side for this problem, but we do need to know the height that we found in the first part, which is 4.138 centimeters. So all we need to do is, as if you were finding the area of a rectangle, multiply the base, 25 centimeters, by the height, 4.138 centimeters, again using stored values in your calculator to get exact amounts, and you come out with about 104.443 centimeters. So we finished all of the parts of the problem. Thank you so much for listening.